Good morning, everyone. My name is Bjorn. I'm the founder of Penguin. It's a big pleasure to be here today. This is Santi Racca. He's our lead developer at Penguin. Way smarter than me, so he's going to actually talk here. I just want to intro you guys really quickly to what is Penguin. Aside from obviously being the next evolution level of a human, before then the penguin jumps in the water and is in its full environment. We're going to have a nice chat this evening at 6 o'clock at the peer-to-peer stage about how we at Penguin transform energy into human potential, which really puts what we do at Penguin in one simple phrase. We are, on the one hand side, having a very big data center in South America, in Paraguay, the heart of South America, where we, among other things, host a lot of Bitcoin mining. And then making use of the excess capacity we have available in Paraguay, which is 100% renewable, we are using the proceeds to fund education of programming. So we have a programming academy called Penguin Academy, where we've been training around 3,000 people to program up to date. And one of the things we do is we train them on very exciting topics that are related to our heart, deep in our heart, which is, of course, Bitcoin and Bitcoin script. So we're trying to get people onboarded on, what is this, how does it work, and especially how can we make build more on top of it. Mm-hmm. And so out of this idea that we really want to make use of the ecosystem, push the boundaries from a programmer point of view, the idea of this talk came out, and a lot of work that we're currently putting in to create new locking scripts, and a little bit like the innovation that in the end led to Lightning, right? Which is just using what there already exists and using it in an incredibly beautiful and smart way. We're trying to mess around with it and see where we can get to. So Santi's going to share a little bit about the journey. On the way, we're going to explain a little bit about some of the basics, which we might skip depending on your feedback. And so that's it. Enjoy.
Thank you. It's working. Can you guys hear me? Perfect. When Bjorn says that we mess around, we don't actually mess around. We try to do it as safe as possible with a locking strip. So just keep that in mind. Quick show of hands. Technical people in the room, raise your hands a little bit. Okay, we got like half and half there. Bjorn's kind of doubting he's in the middle, like doing this right. All right, just to joke, because So the talk is what in the name of Satoshi's are locking scripts. Thank you so much, Patty, for the name. And I am Santiago Racca. I am the principal engineer at Penguin. I wouldn't necessarily consider myself an expert in Bitcoin development, but I have been doing software engineering for about over 5 years, mainly on artificial systems. And what I do consider myself is a hacker. So what I want to do today is kind of go through the journey that I went through when I got into Bitcoin development and show you the conclusions I came to. And hopefully, by the end of this talk, you'll get as excited as I am and as my team is about what locking scripts actually are. And one thing that I want to just start off right the bat, when we think about smart contracts, we kind of think about some Ethereum-based smart contracts somewhere there that does some, like a lot of code and some weird stuff, right? But what I want to do now is have you guys think that locking scripts in Bitcoin can be thought of as smart contracts. And if I can get you to think about that when we leave today, then I think we're in the right path to start building some really cool applications. So without further ado, let's start. So again, as Bjorn was saying, I didn't know how technical the crowd was. So I'm going to do a bit of a refresher. If you guys already know this, and you can just tweet about this right now and say how boring this guy is and he's repeating all this stuff, right? But as we all know, that Bitcoin is a computer program that runs in a network of nodes, a network of computers that basically holds a list of transactions, right? They're all connected, all sharing this one file that holds all the transactions. Roughly on average, every 10 minutes, a random computer node will add a new block that holds a new block of transactions into the network, and thus creating this blockchain, right? A block being added to a block to a block, we can think of it as a blockchain. One thing, if you guys have questions, you can just start asking them right now. I'd rather have like this kind of dynamic where we ask questions rather than me presenting like one of those professors. I used to hate them. So every 10 minutes, we get a random computer node pushing that. We call that process mining, right? So it's a competition between computer programs, between the nodes, to have this one block being added. And why do we do that? Is to solve the double spending problem. It's what Bitcoin actually was meant to solve, so that I cannot send the same coin to two different people. It's actually what Satoshi brilliantly did. How do we actually mine? And this is very important, and I know this is pretty much the best explanation of a hash function you will ever see in your life, because if you get anything more technical than this, you're going to kill me. But basically, what a hash function is that you put in data, and the hash function will spit out a random number. Now, the thing about this random number is, one, it's unique, and it's the same size. And that's a key point in this. It's unique and the same size. If you change anything about the data, then you will get a completely different hash function, a hash result, or another random number. And this becomes very important in a lot of different places in the Bitcoin network. So please keep this little beautiful design that I made about hash functions as we go further along. Questions there? I think we're good. I think we're very good. Still on the basics. So, what miners do is they use compute power, electricity, to continuously run this hash function until they get a number that is below a certain target. I forgot I have this little thing here, below a target. The target is something that the whole network agrees with. It's a number. And if you get a number below the target, then you can mine this into the blockchain, right? And it's called also like the difficulty level. It's how much you kind of have to mine before you get it, and it randomly changes. So what you do, a miner, what it does is you change the data just a little bit, normally just the nonce. So you try a number, it's not working, then you change a little bit of the data, you try again, and we actually do that probably like billions, trillions of times a second in a huge mining farm, right? Once you get below the target, then you get a block reward. This is how Bitcoin is actually created. So the first miner who does this, roughly every 10 minutes, will get his block mined into the blockchain, and they will get a block reward, which at the current time is about 6.25 Bitcoin, if I'm not mistaken. And that's actually how you create Bitcoin in the Bitcoin network. It's called the Coinbase transaction. All right, all good there. A little bit of the basics, coming into slightly more advanced stuff, but still a little bit of the basic. But this is actually very interesting. When I was here, what I found is that a lot of people in the Bitcoin community have a lot of knowledge of how mining works, of what is actually happening there and how do you exchange value. But the second we start getting deeper into transactions, it gets a little bit more gray, right? So I want to spend some time on how do transactions actually work in Bitcoin. And this actually blew my mind because, oh, wait, can I go back one? Perfect. No spoilers there. So when you think about how to send money to someone, traditionally what your head thinks is, okay, I have money and I send the money. So you can imagine I have money in my account and the money something flies over magically and then lands in another account, right? That's what you would think of traditionally as I'm sending money. That is not how Bitcoin works, right? And how Bitcoin actually works is first you have this kind of digital storage space right here. So you can think of the blockchain as having like this digital container, right? And in that digital container, you have different little boxes, right? I like to call them little boxes, or at least my girlfriend likes it when I call them little boxes for some reason. So these little boxes are called outputs. And this is a very important word in Bitcoin, outputs. The boxes are actually different sizes. Like there could be different, let's say, some bigger boxes, some smaller boxes. And why are they bigger or smaller? Because they hold different amounts of Bitcoin in them. This Bitcoin is called outputs, and they're called outputs for a reason. The Bitcoin blockchain, unlike EVM chains, are UTXO model chains. So UTXO transactions. It means unspent transaction output models. What this basically means is that all Bitcoin is always stored in an unspent transaction. And how do you actually send that unspent transaction? Well, you start by unlocking and locking it. So when you want to send Bitcoin to someone, you don't actually send them something. What you do is you unlock your little box, you take out that Bitcoin, and then you create a new box, a new output, and you lock it again. And this is that's all hardware. That's everything you have to know about transactions, is that all you're doing is unlocking Bitcoin and then locking it again to the person you want to have the Bitcoin that you want to send. So it's called unspent transaction output model because they're not spent yet until you use them, and then you can never use them again because you spent them the other way, right? So you can kind of think about it as you are unlocking, you select your output, only you can, and I'll explain a little bit about that later. and then you lock it again to whoever you want to send it to. It's very important that once you lock it to that person, then obviously you can't use it anymore. Otherwise, it wouldn't be that safe. But what if you don't actually want to send, for example, all your Bitcoin to somebody? Let's say I have 10 Bitcoin in one of the boxes, and I want to send it to Patty. I want to send 2 Bitcoin, or 8 Bitcoin, let's say. But I want to send the whole 10. How do you do? Well, normally what you do is you can have multiple outputs in Bitcoin transactions. A UTXO can have multiple inputs, which we'll talk about in a second, and multiple outputs. So you can send it to different people. And one of the most common things to do is to send as a change address the Bitcoin back to yourself, whatever you don't want to send to the other person. And if we move a little bit further into that line, then if the other person then wants to send it to somebody else, they would then unlock that Bitcoin and lock it again to whoever they want to send it to. And it's this chain of transactions that I want you guys to think about when you think about how do you send money in Bitcoin, is you're just unlocking a box, locking the box again, unlocking a box, and locking the box. I'm pretty sure by the end of this talk, I'll be the guy known as, he's the guy that locks boxes here in this conference, right? So, all good there? Any questions? Are we good here? Perfect. So, kind of as a quick summary is that when you use the output to lock it and then unlock it again, you can never use that output again, obviously, right? Otherwise, it wouldn't be secure. So you have this little flow of transactions 1, 2, 3, where you're locking and unlocking and locking and unlocking constantly. So, how do you actually unlock it then? What makes it that I can unlock this particular box of Bitcoins, and how can I lock it again? Well, in Bitcoin, what you do is you have a private and public key. And you could kind of think of a private and public key as being the private, your password, and your public key, your account number. It's not really that analogy, but it's a good way to think about it, like a simple way to think about it. So what you do is, when you want to receive Bitcoin, you give somebody your public key, right? The public-facing key. And then they lock that Bitcoin to your public key, as you can see right here. And then when you want to unlock that Bitcoin, you use your private key to unlock it and then lock it again. So you kind of think of it as I have 2 keys, where I unlock with one and I lock with the other. And this is the system by which you can open up the boxes in Bitcoin. Gets a little bit confusing here, so please stop me if you want me to repeat it, but it's pretty cool actually if you think about it. But this is the way that Bitcoin is secure. So if you understand this part, then you understand that this is exactly how we can have a system of safe, secure transactions without having a centralized authority, which we all agree is extremely cool, right? So what you do is, for generating a private key, really quick part, this is actually important. A private key in Bitcoin is nothing else but a random number that just has to be below a target, a maximum number, right? Which is the maximum 256-bit number you can possibly achieve. It's just a completely random number. Anybody can generate it, and it's all good, right? What the actual magic is, and I call it magical mathematics, but it's actually called elliptic curve mathematics, or elliptic curve multiplication, is that the public key is derived, this is the public right here, derived from the private key through elliptic curve multiplication, right? And I'm not going to get into that right now because you guys are going to shoot me in the face if I start to explain what happens during those moments. But the key thing to understand about this is you can derive the public key from the private key, but you cannot do it the other way around. You cannot find the private key from the public key, and that is the absolute cool part. Because what it means is that you can expose the public key, even though we don't do that anymore, really. But technically, you can expose your public key, and people will know that you are the owner of that public key because you have that private key. Only the owner of this private key could possibly ever have this public key. Kind of works like that. Any questions there? Pretty good? Awesome. So, with all that random numberness going on around there, when you want to lock a Bitcoin to somebody, or want to unlock a Bitcoin, you generate a digital signature, right? And it's valid for that one transaction only. So you use your private key to generate a signature that proves that you are the owner of that private key. And you pair it normally with your public key in order to say, this is me. This is me, and only myself could possibly ever do this, valid for only that one transaction. And in this way, you can securely send money around without a central authority by just using digital signatures. And this is called public key cryptography. It's been around for like 70 or the 80s when they came up with it, but it's a a way for sending secure transactions throughout the network. It's actually cryptography, right? It's where the name cryptocurrency comes from. That's why it's called a cryptocurrency, because they use cryptography to be able to send transactions around securely. Awesome, we're good there. Perfect. Now we can actually start getting into the really cool stuff, at least the cool stuff for me and my team, but I'm sure you guys are going to love it, at least the technical people. Non-technical people, not so much. So I'll be talking about locking scripts, right, and unlocking scripts, and how you can like lock and unlock and all this fancy work. But what is actually happening there, right? What does it mean to lock it? Well, Bitcoin, actually, when you lock and unlock it, it's running a little piece of computer code, a little programming language called, very appropriately, Bitcoin script. I absolutely love that Satoshi named the scripting language script. It's just beautiful, simple, right? So script is a non-Turing complete language, which means that you cannot compute everything in it. And it was made like this by design. And I think also that's very important, because normally when you have a Turing complete language and you're mixing it with cryptocurrency, there's a lot that could go wrong, right? So you kind of want to limit it and scope it in a way that it's very simple, robust, and straightforward, which allows for quick verification, security, and privacy. And a really rough overview of how it works is, if we're going to have to do it here. So it's a programming language. So the locking script, this little piece of code that you can see right here, is placed on every output. Every time you lock something, you write a little piece of code. Well, technically most wallets just do it automatically, but let's say you write a little piece of code that locks that Bitcoin there. And then to unlock it, you provide an unlocking script, another piece of code, which is normally referred to as inputs. And normally it's just providing, let's say, your public key or your digital signature. That's enough. So when you have a full script, it's the unlocking script and the locking script put together. And the way it works is, you can kind of think of this as well, it's actually a stack, right? So like a stack of books, and evaluates like a stack. You start putting things into the stack and then popping them off. The way a Bitcoin transaction is valid is at the end of the execution, when we get to the bottom of the stack, if there is a 1 left over, then it evaluates to true, and this transaction is valid, and you can spend the Bitcoin. If it evaluates to a 0, or nothing really, if there's nothing left on the stack, this transaction is invalid. And then we cannot unlock the Bitcoin and spend it. And it's pretty much that. So if it evaluates to true, you can use it. If it evaluates to false, you cannot use it. I think this is one of the reasons why it was a little bit intimidating to start writing complex smart contracts in Bitcoin. It's because the language is a little bit low level, a little bit, let's say, limited in a way. And it's a little bit intimidating to write things like that and think that if I don't end up with a 1, I'm done, right? I lose my Bitcoin. And I don't know how many programmers there are in here, but we are prone to make mistakes, right? So we want to, and especially we don't want to test our code, so that's probably also a reason why we don't want to do so much here, right? But here, again, we see an example, you can do it actually here, of a locking script where you are basically hashing twice a public signature and then checking if it's equal with this checksig opcode right here. And just to reemphasize, the full script is the unlocking and the locking script. Where do you find this? Well, as I was saying, you find it on every single transaction. So you can imagine that this is an output, and you want to lock it to somebody. You provide this locking script right here. And you lock the new output with that piece of code. When you want to unlock that Bitcoin and lock it again, you provide some unlocking scripts right here, and then lock it again to create new outputs. So it's technically one full script, but it's made in 2 different transactions. So when you lock it, you provide one part of the script, and then when you unlock it, you provide the next part, so you can spend it again. So a full script is the unlocking script plus the locking script that goes in the latter part, but it's technically done in 2 steps. So you can think about it as like I'm locking it, then I'm unlocking again. How are you guys doing? I'm not killing you, right? This is pretty cool stuff, I guess. Perfect. So just a quick re-emphasize here, this will be a full locking script, a full script in total. This is the unlocking script. It goes first. Even though you provide it at the end, at the second step, you always put it first. Because again, it works like a stack. So this is a digital signature, and this is a public key. And this will be the locking script right here. So in this case, we are duplicating a hash, so we're hashing twice, checking against the public key hash, checking if it's equal to it, and then checking the signature, and if this all ends up with 1, then we have a valid a valid script. We can unlock this Bitcoin and do it again. Okay, we're there, we're good, perfect. So then when I was here, I was kind of asking the question, why do we have to have this big programming language or this simple programming language to do all this? If we can just sign stuff and then just use the signatures to like send Bitcoin around, why do we have to have all these locking mechanisms and code there and add complexity? What's the whole point of this? Well, the point of this is that you can actually do some pretty cool stuff. You can actually create some different kinds of locking scripts. And I'm going to give an example that I find to be very funny, but I encourage anybody to not do this at home, please, because it'll be, unless you're kind of like Elon Musk style and you just want to send your Bitcoin away to everybody, it's like, you don't care, more power to you. But here, we see a locking script where as long as you provide 2 integers that add up to 8, you can use that Bitcoin. No signature required at all. This will take a little bit more time to mine into the blockchain because it's a non-standard script, but it's technically still valid. Here we see a very simple locking script that's add 8 equal. So when you provide 2 numbers as inputs right here, then you would unlock this Bitcoin because 2 numbers that add up to 8. Okay, they're equal. Okay, valid output, or valid script. Let's send this Bitcoin. So this is actually valid. Quite stupid to do because then the first person who can actually do it, or provide 2 numbers, you gets that Bitcoin. But I guess if you have a lot of Bitcoin, then you can do it.
What are the chances that somebody will notice if you send this?
Well, yeah, I mean, I thought about that too, right? So they'll be having to monitor the network quite constantly and to do that. So I guess it could be a funny joke, right? To kind of do that and do some little hacks over in there. I just wouldn't put a lot of my Bitcoin there. that would be my kind of thing. Sir.
Sorry.
Then how does the person inputs the 2 number into the transaction?
That's provided as if I go back here, so you kind of see here, right? Here, right? So this is like, in this case, they provided 2 inputs, which is the digital signature and the pub key. Then what you would provide in this one is 2 inputs, being the 2 numbers, just providing tas as an unlocking script.
Okay, so you wouldn't provide your key in that case?
No.
Just the 2 numbers?
That's why it's so dangerous, right?
Okay.
It's so dangerous because it's like, just put 2 numbers, you're good, right? Imagine 100 Bitcoins right there. It's like, my lord. But the point I want to make with this is that I've seen people do Sudoku puzzles like this. Just provide the answer to the Sudoku puzzle, you get this Bitcoin, or zero knowledge proofs. The whole point I'm trying to make here is it's not just digital signatures that we have to use. We can do other stuff. And it starts to get a little bit interested as we go a little bit there. So I'm just going to roughly talk a little bit about some of the most standard scripts that exist or have existed. You probably heard about these if you've been hacking away in Bitcoin. So for example, the first script that was pretty much used, a very standard basic script, is called the pay to pub key. It's basically you provide a digital signature in your pub key and you just check it. You check the signature. If this is valid, if they match up, then it's all good. Then we have the pay to pub key hash. So in this case, what we wanted to do is provide a little bit more privacy, a little bit more security. Technically, the pub key is secure. You can provide it, but just to be extra safe, we don't provide the public key. We provide a hash of it. So in this case, this is the hash of the pub key, and you hash it twice with hash 160, and you provide as input your digital signature and your pub key, and you check if it's verified, if it's equal, and then you check the signature, and it's all good. The third one will be a pay to multisig, so it's also pretty common if you heard about it. So in this case, we have a 2 out of 3 multisig, and this is very interesting because we hear these terms, right? So it's a multisig, it's a 2 out of 3. Like it's thrown around very like casually in the Bitcoin community. But what does it actually mean for it to be a 2 out of 3? Well, this is literally what it actually means to be a 2 out of 3 multisig. In this case here, you have 2 inputs, 2 signatures, and you're saying you need to provide 2 of these 3 pub keys, 3 because I put it here, that you must check for a multi-signature, and you have a check multi-sig. So again, these are the things I want to point out. When we hear these terms, if we can just sum up that this is what it's actually doing, it's running a little bit of code and checking if it's valid or it's not valid, then we start to build some very interesting applications. Suddenly, it doesn't become as intimidating as we would think it is. Because if we are able to just properly write these locking scripts, we can start to put some very interesting functionality. The one that's probably most used today to extra secure the network is a pay-to-script hash, is where you don't even provide the pub key. What you do is you hash the actual locking script and then have an image, a pre-image, that when hashed will give you the original locking script, and then you can provide that to unlock the Bitcoin. And it's just a safer and more robust way to do it. You can also kind of store data in the blockchain if you just do the up return. So if you do up return, it will like be invalid, but because it has data, it would actually still be in the blockchain. And now you have data on the blockchain. Okay, I kind of got myself ahead there. So with all these questions there, kind of like standard scripts, I want to do a little bit of like an exercise to think about what we can actually do as we start moving into more advanced stuff. So what we do here now in Penguin is we're trying to see, well, how far can we take this? What are the limits? What are the upper limits of what we can do with lock-in scripts, right? We're also very conservative in terms of changing the Bitcoin protocol. We believe Bitcoin is a sword, and it's used as a sword, and some people may want to use it as a Swiss Army knife, make it do a little bit of things. We don't really like that. So what we want to do is keep it like that, but then see how much we can innovate on top. I know it might be limited, but how much we can actually do. So where is the upper boundary? I believe that we haven't found the upper boundary yet, and we're here to explore that. So let's start to think about, for example, I want to open up a college fund for my son. Right? I want my son to have a college fund. And how might I do that? But I don't want to put it in a bank because we all know. So what I would do is, sorry, I got ahead of myself, no spoilers, is I would program a lock-in script where I would put a certain amount of Bitcoin that represents the amount of value I want to put for the locking, for the college fund. But if he's my son, he probably wants to spend it on a lot of stuff that I don't want him to spend it on it, because he's probably not very mature yet. So I'm going to say, I'm going to lock this Bitcoin with a time lock, another part of a locking script. And he can't use that until he turns 18. So in a locking script, when you put a time lock, you can actually say until a certain block height, which can be calculated based on the 10-minute interval, or a Unix time, like seconds, since 1970. So I could just lock this Bitcoin saying this, my son, with his private key, can definitely unlock this if and only if time has passed enough that he's 18 and now he can unlock it. And it's super verifiable by anybody. Anybody can see that my son will have this money at 18, but not before, right? Definitely not before. I might even increase it to 20 and 21. So that's good. You see, we have just thought of a college fund locking script, something that might have not come up initially or intuitively if we're thinking about locking scripts in Bitcoin. But then, as I was thinking this, my wife, who is a way smarter lady than me and much more careful, right, said, think about the case that we might have an emergency, that maybe there's something wrong, or there's like family emergency, hope to God they know, but what if we have to do it, right? Or a down payment for a new house or something like that. We should be able to somehow withdraw that money. Because if only my son could do it after 18, what do we do? Well, let's take it a step further. We had this initial spending condition where it's my son only if he turns 18, but then I could add another spending condition, which is me and my wife's signature, so a 2 out of 2 check multi-sig in the case of an emergency, so before the time lock. So now we have a quite smart contract, let's say, right? Something quite smart that we can use as a college fund for my son that anybody can verify that exists, or me and my wife in the case of an emergency. And this is where I want your head to be going. What you be thinking? How far can we actually take this? Where are we actually going? And moving on to what we're doing right now with Penguin, at Penguin we are trying to work on digital securities, right? So something that's traditionally not been done in Bitcoin. Specifically, what we're trying to develop is a hash rate token. Give somebody the ability to invest in hash rate without all the hassle of having to set up all the equipment and keep up all the mining operations and such. So how do we do this? Can we tokenize hash rate and then be able to sell it? And here is the kicker. All based on the UTXO model with no counterparty risk. So is there a way that nobody has to actually hold the Bitcoin for your security, minimizing counterparty risk? Can we, simply by the use of locking mechanisms, create a token that has a non-custody, as a non-custodial, let's say, that it's only held by the blockchain itself, merely through the use of locking scripts? Now, if that doesn't blow your mind right now, as soon as you start getting to locking scripts, that'll be like, wow, that's actually quite crazy. Sir?
Can you put conditions on the output of the transaction spending the UTXO as part of the locking script?
Can you put conditions on the output being spent.
Yes.
So like when you lock it again.
Yes.
So when you actually just you have the output, that's the output already has a lock on it.
Yes.
So you have to give an unlocking script,
Yeah.
and then whatever you use on the next one, you lock it. You can then
Part
that's
of
a
the
condition.
condition.
That's
Yeah.
a condition. The issue with this one that's interesting is it's kind of like time locked until maturity date for it kind of acts as a futures contract in a way. So technically he can't spend it, and we're sending those transactions constantly. And the issue kind of arises when you want to make it, for example, exchangeable in between people. Because then you have UTXOs being locked to somebody, but then that person has traded the token. How do you actually redirect those UTXOs, which we know it's impossible? How do you think about that? And I kind of want to show where we are right now in terms of what is capable and what we're doing. The first thing that I want to show
Sorry,
is...
one question.
Oh, so sorry.
I didn't actually understood what would you like to achieve with Penguin.
Oh, okay. Just give a brief refresher. It wasn't the point to talk a lot about the actual token, but so what we want to do is we have a hash rate. I think Bjorn was mentioned we have hash rate in Paraguay, and we constantly mine. We want to give investors the ability to tap into that hash rate power by purchasing a digital asset, which represents a security on the hash rate, and then hold that as a kind of a futures contract. So they will get all the Bitcoin that's mined from that hash rate straight to their wallets. They're just not going to be able to use it until maturity date, and then can use that as a futures contract. But they could also possibly exchange it with other investors, qualified investors. And then the issue arises, the innovation arises, is how can you allow for the trade to happen in between different investors if you are already sending UTXOs straight to the original owner? It's kind of where the innovation kind of happens. Does that make it a little bit clear?
Yes, thank you.
Super. So one of the things that we were looking at is Taproot and specifically Mast. So Taproot was an upgrade to the Bitcoin protocol. It allowed quite a few things, but the one I want to focus on is Mast. So Mast is short for Merkleized Abstract Syntax Tree. So what that's horrible, like it's a real tongue twister right there. But what the Mast does is, I've talked about a little bit how you can hash a locking script, and you can have this one locking script being hashed. But remember, there is a size limit in Bitcoin to how big their transactions can be. So traditionally, there has also been a way or a limit to what we can actually do with smart contracts. You just can't write endless amounts of code. So how do we manage that? Well, what Mast allows us to do is to have multiple spending conditions, multiple different scripts, and then hash those scripts into a Merkle root. So Merkle roots are basically the root hash of hashes of different leaves in that tree. So with this, what I'm thinking, what I want to explain is, you can actually pay to just the root hash as a script hash. But you can have multiple different conditions. And the way it works is, you don't have to publish all spending conditions. You just have to publish the one that you use to spend the output. So where our heads are kind of going in our R&D is that, can we actually build large and complex computational logic into different spending conditions? So you have different parts of what we can actually achieve with this, but it's secure and private because you only publish the one that you actually need to use. Thus, we create a large and complex smart contract that can allow for multiple things to happen, kind of in a way to think about it, it's like features in an application, I guess, and then just use the feature that we need in order to provide the output that we need. The other stuff that we're looking into is obviously, how do we digitalize assets, right? So that's not something that we are doing on the main chain. Not that I believe that we should do that on the main chain, but that's why we're using Liquid. So Liquid is a second layer solution for Bitcoin, and it allows for features such as asset issuance or digitalizing securities, faster transactions, confidential transactions, and faster settlements. And this is also where I believe a lot of the stuff can happen. This kind of like cohesiveness between the main chain and the side chain, where the main chain can be kept as pure as possible, as simple as possible, as a robust way to store value, and then side chains can be used for additional features like asset issuance or faster transactions or other kind of stuff that we can use around their APIs. They have a wonderful API, it's called the AMP API, which basically allows for asset issuance and then a lot of checks for whitelisting investors or categories and doing all the kind of fancy stuff that I wish we were working on, because we're still stuck in that locking script. So if any of you guys want to help out, we are here, right? And then the other thing I want to show you, oh wait, no, right before, Cloud, can you help me do we have a little Notion there I set up. It was no time to do the actual presentation for this one, but there we go. No stealing our Notion, guys, please. But this is kind of where we were in the R&D. I just want to show you kind of how we did it. So we have what I call leads, right? Different things that we're looking at in order to like solve this problem, and it either ends in a dead end, what I call it, or a solution. And hopefully we find a solution and we advance it. So we're looking into, for example, Taproot. We're also very interested in time lock refreshes that Liquid also uses. HD wallets, very interesting and promising in terms of being able to have not just, let's say, a simple wallet, but like a master key wallet where you can derive child keys and thus have different permissions like read and write and thus for. We found something extremely cool that I encourage anybody to look at. It's a S-script compiler. It's basically a compiler for Bitcoin. It's a higher level language that allows you to like write really high level and then compile to low level, which I would not encourage to do directly. I would use it kind of as a debugging mechanism. So if anybody is a programmer here, you know how hard it is to kind of write low level and think low level all the time. So if you can be a little bit higher level for a second and have your mind going quick, and then reach a solution, and then we can go in there. It's technically not on the main chain of Bitcoin, but it does compile to Bitcoin script, so it should be valid. And they are doing some very interesting stuff, even throwing around concepts like stateful contracts, which I thought were quite interesting. To check out. From there, we're also looking, for example, at OBO push or pay to Taproot, and it's kind of a way to like store data in the network, and what can we possibly do with that if we can store like certain conditions around that. And with that, what I want to then also end with is we are not obviously done with all this. We are starting. This is a journey for us. And what I wish, or at least to encourage the people here, is that anybody that's interested in this, anybody that wants to explore where we can actually go, how far we can take the locking scripts, what else can we build, what can we innovate on top of that. If anybody wants to join that cause, we'd be happy to partner up and see actually how far we as a community can take locking scripts and develop some next generation smart contracts built entirely on top of Bitcoin. And if we're able to do that, then I think it will really shine a light into how Bitcoin is a store of value, a sword, but also a means to create truly decentralized applications for the future. Thank you very much. Questions still here? We got questions? I think Patty's already crying, man. It's 10:30 in the morning, man.
I have one about like a couple of slides back.
Oh, sure.
So
Clive, can you help me out here? I'm a programmer. I don't know how to do PowerPoint. I refuse to learn how to do PowerPoint. It's not my game. Not my game.
Yeah, the one before this. So in this case, what are you actually storing?
The
only?
hash.
The hash only?
So what you do is you pay to the script hash, and you would pay to this hash.
But then this is just a proof of what you're doing. It's not like gonna run or anything.
No, of course, because what you do is then would you... Hello? All good? Yeah. I got cut out, man. I'm sorry. It was the IP, right? He's about to do IP. Cut him out. So what you do is you pay to this script hash, right? And the way you do it is if you have the original script, you can derive then the hash, right? So what a mask allows you to do is that you could have all these different scripts, and then by providing only one of them, you can derive the Merkle root, and thus you don't have to store all of them. So you can have multiple conditions. By providing one, you can derive the root of that.
My only question is that then when is this going to, let's say, run, or where am I running this the derived script?
Where are you writing the address?
No, the derived script. So I have the hash. Let's say I derive it back.
Oh, okay. So let's say you would have an output, right? And so you lock it to this, right? You lock it to this Merkle root. And once you want to unlock it, then you provide that pre-image and then you use it. Once you want to unlock the Bitcoin. Does that make any sense? Perfect.
Hi, I have a sort of a non-technical question just to see if I can...
I don't do those.
If I can understand the concept.
Yes.
Yesterday, I saw the really important innovation, the beer dispenser. So you pay with Lightning.
Yeah.
And when the transaction is valid, it dispenses beer.
Perfect.
Okay, so event occurs, judgment is made, is it valid or not? Action occurs, the switch is tripped. But then once that state change occurs, you can do anything you want. You can use it to dispense beer, or to start a car, or to launch a rocket.
Yeah.
Okay, so that's the sequence, yeah?
Yeah, I guess you could kind of look at it like that in the case of if you're integrating a script into like something else.
Yeah.
Is a script at the end of the day is once you reach the end of the stack, if it evaluates to a 1, which is true,
Yeah.
then this is valid script and you can use that output and do pretty much what you want with it.
Yeah.
If it evaluates to a 0 or an empty stack, or if there's anything else than a 1 in that stack, then it will be false and you just can't use it. So I guess in this case, if you go from events, once it's valid, you can move into some other integrations, I guess.
But this seems different to me because when you evaluate the conditions, is it 1 or 0, the result does only one thing. It releases the money.
Yes.
So now you need to build the complexity at the beginning. What are the conditions that would cause the event to occur so you can release the money?
Yeah, and okay, I see where
Is
the
that
question
it?
is going. Very interesting, and also what we're doing with Penguin with this hash rate token, right? So the true challenge that we have is innovating on the lock-in script in order to provide a non-custody way to invest in mining. But obviously that's not enough. What you would also have to do is build infrastructure around it in order to work with something tangible. In the case of a beer dispenser, then that would be, for example, okay, once you press button and then choose beer, evaluate script, perfect, then dispense beer, or something as complex as a hash rate token. So I guess to answer the question is the lock-in script is one part, which is basically just a smart contract to unlock the Bitcoin, but then you would have infrastructure APIs around it to do stuff with that.
That's it. So when you're building the complexity before the event, the conditions, are you building that in script, or can you use another programming language?
So
build the
script
series.
is strictly for the locking mechanism of outputs and the unlocking of it. Everything around that you could build with something else.
Great. Thank you very much for helping me with
But I
that.
would encourage you to not use PHP.
Okay.
The programmers got that joke. Patty, why are you laughing, man? You don't understand that. Sir, yes.
High-level explanation of how? Can you give a high-level explanation of how and if it can improve self-custody?
How if?
Yeah, how or if it can improve self-custody, making it easier, even a collaborative custody with.
Okay, yeah.
With the time.
How can it improve?
Yeah.
Well,
make it easier.
yeah,
better UX.
I would say, well, easier, it's one way to look at it, but also, let's say, safer. More transparent is even a better way to say it, right? So if you see examples, let me go back to for example, an easy one, or this one we're just checking, right? And if you go back to this example where you have this input right here of the digital signature and the pub key, and then the login script, I know it's very cryptic, but it's very also readable and transparent. This is exactly what happens, and nothing else could ever possibly happen. So by having code be your means of self-custody, what you're actually doing is, well, pardon the pun here, locking it. So it can be this and only ever this, and there is no way to be other, right? This could also be a little bit dangerous if you think about it, if you do it wrong. But by it being just code, we can stop relying on third parties. We can reduce counterparty risk. Because what I think is that the second you are putting the Bitcoin into somebody's control and they have control over it, then the risk increases, right? Because they might be prone to do something, maybe not, but then you're in this kind of like, what if this happens kind of way, right? This could happen, or maybe an emergency happens, and humans are creatures at the end of the day, so they're prone to do actions. But code is not. Code evaluates always purely. It's mathematics. So by having login scripts as your means of self-custody, you are saying this and only this. And it's also a way to be very transparent, because you can show this to anybody. You can show it to your parents, to your girlfriend, to your wife, to anybody, and say, this is it. So an example I gave from the college fund, for example, if I lock it to my son's private key, he can only use it until 18, and that's it, right? There's nothing else that I can do with it. It will always just be that. So nobody can ever claim that, oh, well, you might be doing this or that with the money. I cannot. the locking script is very clear. It can only be done this. And I think that is very beautiful in a way. And a lot of why Bitcoin is about. Transparency, like openness, security, and privacy. Okay. I don't know how we're doing time. We're good? Awesome. Thank you, guys.